All right, off we go. The first topic of today is what is the point of JavaScript in the first place? And so JavaScript is a scripting language, which means you don't compile the program in advance and then execute it by like double clicking on something. Rather, you run it through and it executes from top to bottom, line by line, which opens up for some really cool opportunities. You can put something together really, really quick in a scripting language, whereas you don't have any of the boilerplate of something that has to be compiled, and it requires a lot less setup on your part. And the main point of why you would want to use JavaScript is if you want to interact with a web at all. So the holy trinity of the web is HTML, CSS, and JavaScript. HTML and CSS are great, but you can't do anything super interesting without JavaScript. You can create a web page, you can make it look pretty, you can maybe have it make a couple of nice CSS animations, but until you actually include JavaScript in there, nothing is super interactive. You can't manage a user's data, you can't do a bunch of cool things. And so that's where this comes into play. There's a lot of things that happen on the web. Like if you just think about your favorite company, everyone has at least a website that tells you who they are, and maybe you can sign in, sign out. All of that is done through JavaScript. And a lot of companies operate specifically through the web as well. So it's not going away anytime soon. JavaScript is really cool because it supports a lot of different styles of programming. How many of you guys have like heard of object-oriented programming before? Okay, most of you have. Most of you probably haven't gotten there yet in your course load. But you can do object-oriented programming in JavaScript if you want, which is useful a little bit if you get into more complex JavaScript programs. Personally, I don't really use classes very often, but it is something that's supported if you want to. How many of you guys have heard of like functional programming before? Okay, a couple people. So functional programming is another style where all of your data is immutable by default, which means you have just like something in a variable and you can't change it. And instead, what you do is you write a bunch of functions that'll take in data and give you new data to replace it instead. A lot of JavaScript just works like that by default. So you might not even like think about, oh, I'm doing functional programming right now. But it comes pretty naturally. And there's a lot of different ways you can interact with it depending on what you need. And then the last thing is it's primarily run in a browser engine. So pretty much like the way that you would think about using JavaScript is to make your browser page do something really cool. But there are other ways of using it, which we'll explore a little bit later. I put in a history slide in here just in case anyone's curious, but it's very old. That's the takeaway here. The first like browsers that people were using with a graphical UI were like in the 1990s. And at that point, the only thing you could do with a web page was create something static. So an HTML and CSS together, and it wouldn't do anything. Everyone would get the exact same thing when they went to a URL. And so what they wanted to do was create a scripting language that can actually create some interactivity and do some interesting things. And so originally, the syntax of JavaScript was based on Java. This was around the time that Java started to become a thing and everyone was super excited. And they kind of bought in on the hype. They originally called it LiveScript, and then as a marketing ploy, changed it to JavaScript because everyone thought Java was really cool. There are some things that are very similar to Java, but if anyone has written any Java before, Java is like very structured and you know what's going to happen for the most part. JavaScript is wildly unpredictable and you can do a lot of things, very dangerously, which you couldn't do in something as Java. The other important thing here is that there's a thing called ECMA script, which is the language specification for JavaScript. And this gets updated every time they want to add new features. And it defines a standard implementation that everyone who creates something that runs JavaScript needs to support. There are a lot of different places you can run JavaScript. All of the browsers have their own engines for running JavaScript that's created uniquely. So the one for Firefox is different from the one from Chrome. And they can all implement things differently if they want to, but there are certain things that have to be supported at this version of JavaScript. If you've ever been to, hold on, let me dip out here for a second. I wonder, no, this is what I want. I think I don't know what I want exactly. Maybe the Mozilla Docs has a big table to demonstrate this. Yeah, so if you go into any sort of reference for a for JavaScript or something web-based, oftentimes at the bottom, you'll find this really disgusting browser compatibility table. This one's kind of nice because it's all check marks, which means, yes, we can use an array in any browser, which it's like, that's not something we're worried about. More specific, like recent features may not be supported in browsers, but the reason is because every browser has its own engine and supports a different version of that ECMA script. And so when you're writing something, the JavaScript you write might not be supported in every single browser that people are using. And so you have to go ahead and think about, if it's not supported in this, what can I do instead? Can I use something else that does the same thing? That's sort of where these tables come into play.
Is ES6 a version of this ECMA script?
I believe so. There's ES6 is very old at this point. I think we're at this point, the versions that are released are like after the year. So I think there's like a ES20 or something. I don't remember exactly. The versions are really complicated. Usually you can use the most recent version. If you end up in a like worrying about browsers specifically, it can get a little more hairy. But in other forms of using JavaScript, like we had mentioned earlier before some of you guys were here, we're going to talk a little bit at the end about Node.js, which is a different way that you can run JavaScript outside of the browser. In that case, it doesn't really matter because like you're not competing against several different runtimes. You have exactly one runtime and it either works or it doesn't. So in that case, it doesn't really matter what version of JavaScript you target. It's just whatever features you want to have. Let me get this overlay out of the way. I really wish that you could minimize the zoom overlay at the top. I don't know why you can't do that. It's really annoying. All right, we are going to jump into some live coding. And at this point, everyone should open their laptops so they can follow along. If you have an environment set up already for JavaScript, great. If you have VS Code, you're welcome to use VS Code. If you don't have anything set up, you can literally just open a notepad and write in the notepad. But here's what we're going to do. So I'm going to find somewhere on my desktop. I'm going to set this up all weird. I'm going to open folder, and I'm going to go ahead and put this on my desktop here. I didn't want to do this. All right, hold on. I'm going to do this from the command line. All right, I'm going to create a folder and open that folder. And make sure you know where that folder is because we're going to be running this a little bit. So there's, if you're interested in just like testing something out really quick, the easiest way to write JavaScript is literally in your browser. Like you can right click on any page and go to inspect. And if you open inspect, it'll give you this very large menu of all kinds of tools that you can use if you're a web developer. So all of these are useful. This element section shows you like what the structure of your page is. So if you're curious if something's like actually in there or if you're having an issue, you can look through. The network section helps you figure out if you're like sending requests to a server somewhere, if they're actually going through or what the result is. But if we go into the console section, the console is what we're going to do. You can write JavaScript in the console at any time. Like I could write a variable in here and then log the variable. So if you have something that you just want to like test really quick, it's very easy to do it in the console. We're not actually going to do that because it's kind of a pain if you're writing like a bunch of things at once. And instead, what I'm going to do is I'm going to create a random HTML file really quick. We're going to put in the tags that are required in order to make this work. Oh, shit. We'll make a body tag. And then we'll make a script tag, and we'll set the source equal to test.js. Oh my goodness, this is so many people. I apologize for not having a space that big enough for everyone. There's one seat up here in the front. And then other than that, maybe I'm almost out of space. If you can't see anything, just let me know. I'm so sorry. We reserved the space for the amount of people we normally have, and this is way more than we normally have, which I'm super excited about. So this is the very basic structure of an HTML file. We're literally just going to use this to execute our JavaScript in the browser. We're not going to like put anything in here. But if you wanted to, you could put a bunch of other tags in here. The only thing you really need in an HTML file, which we're going to cover because I don't want to cover everything else, is just this HTML tag that says everything inside is HTML, and then a body tag, which is where the main content of your stuff is. There's also a header tag where you can put like meta information about your sites, link a bunch of stuff, but we don't need that here. This is all we're doing. We're just creating a page that's blank and we are inserting a script. And I'm going to go ahead and take that script and put it in another file in the same level. And let's just make sure this works. We can console.log, which is how we print anything. And that's all you need. You can put a semicolon on the end, or you cannot. Semicolons are optional, which is great. And then let's go and find that file that you just created, which is on my desktop. And then right-click on the index.html, open with Google Chrome. And that will go ahead and open it in your browser. And this is where we're going to try everything. Let me also make this bigger. I'm in the exact same level. I'm trying so hard to close this menu. There we go. This should be all you need, and you'll know if it worked by going into your browser. Once you open it, inspect, and go to your console. All of your JavaScript is going to execute in the page. Anything you print goes to the console. We're going to print a lot of things here. Show of hands, how many people got this to work? Okay, lots of people still working. Take a pause. Does anyone have any questions? Anything not working? What's up? Like up here? VS Code should have a bunch of icons by default, but there's also extensions that change the icons. I don't remember exactly which one I have. I think it might be like material. Yeah, material icons. It's an extension. Your extension section in VS Code is where you can get support for different languages. If you have one that you want to write in VS Code, just get the very top listing when you type in that language. It'll usually be syntax highlighting or linter or something for that language. If you're using VS Code, I think you can install ESLint, which is the extension for helping with JavaScript. It'll autocomplete some stuff. It'll highlight everything. It'll help you out a lot. All right, go ahead. The only thing you need in here is just to prove that it works. So we'll just write a very quick console.log. All right, another show of hands. Who is still working on getting this set up? All right, we got a couple people. Wait another 30 seconds. And then if it doesn't work after that, phone a friend, meet someone new, say hi. The plan for today is to do a bunch of demonstrations really quick about JavaScript. If we have time, I have a very small project that has a HTML and CSS structure already. We'll write some JavaScript to fill that out. And then after that, if we have more time, we'll talk about some of the more complex terminologies. But I don't want to keep anyone too long. All right, I'm going to keep moving here. If you have any issues, just reach out to your neighbor. Go ahead and keep your index.html loaded in your browser. We're just going to refresh the page over and over again. So keep it up. If you want to split screen, you can. Otherwise, you can just swap between tabs when you need to. All right. So first thing we are going to do is we are going to talk about variables, because you always have to start at variables. Because this is a loosely typed scripting language, JavaScript does not require you by default to specify what the type of your variable is. All we need to specify is an access modifier first. So we have three access modifiers. We have const, let, and var. We'll talk about why they're different in a second. But we can create a constant variable and name it whatever we want. We'll call it x, and we'll give it the number 3. We can console.log x here. And then if we refresh our page, we'll see that it logs 3. So this is a very easy thing. Note that if I wanted to reassign x, and I refresh the page again, now we have an error that we're assigning to constant variable. So the const keyword means that you have declared it, you cannot change it, you have to redeclare a new variable in order to update something. This is very common, as we were saying earlier, during the functional discussion about functional programming. You don't want your data to change. So in this case, constant modifier doesn't let it change. Not my philosophy, but what I've learned is that if you can declare something const, you definitely should. If you know that it's not going to change, just make it a constant. The other things that you can do is you can use let. We'll let y equal 4. And we can also use var equal 5 console.log y plus z. And if we refresh again, now we have 9 and added them together. Let and var mostly do the same thing. We'll very shortly talk about what the difference is. But let and var lets you update the variable after you've already declared it. And for those of you who are already done any kind of programming, which should be everyone here at this point, or almost everyone, we can write loops the same way we would in most languages. We can let x, we already declared x, I is equal to 0, I is less than 10, I plus plus, console.log I. And if we refresh this, it'll go ahead and print from 0 to 9. Same as you would in any for loop, except instead of declaring the type of the variable, we just have to let, which seems is we're creating a new variable. We could also do this. And then take out this section if we wanted to. We'll leave it in for clarity. While loops also work like you might expect. Let j is equal to 0, while j is less than 10, console.log j, and then j plus plus. And that also prints out another 10 numbers. This is very basic syntax. We'll build up to some more complicated stuff. Anyone have any questions about what's going on here? Scroll down a little bit. All right, I'm going to keep moving. That is the end of our basic section. Let's talk about functions. Functions is the other important part of JavaScript. Because it's a scripting language, and our thing executes top to bottom, just all of the instructions you give it, one thing that we can do is we can create a bunch of functions which specify a block of code to run, has parameters, input and output, but it doesn't have to be tied to a specific class like it would in Java. Like it's not a method of a class, it's just a function that exists in our script. We can do this 2 ways. We can declare it with a function keyword and then name our function, say hi. I'm going to go ahead and comment out these loops and all of this jazz just so that it doesn't constantly print over and over again. In VS Code, you can use the control or command, depending on whether you're Windows or Mac, plus question mark, and that will comment out everything you have selected. So we can have a function and then console.log hello world. And then this function just exists. If we refresh the page, it doesn't do anything until we call it. So we can call, say, hi, and now it goes. So the order of operations here is that this function is available, it's declared. We could actually also put it further down. It doesn't have to be at the top. There's still no error here. Yeah, so basically these functions are available at the start of the script. You don't, if you like write some C, like you can't call a function before it's been declared. So you either have to put the thing at the top that like declares the signature, or you just have to put a function before another one. But that doesn't matter in JavaScript. It can be anywhere. Another cool thing, we can declare this another way. We can also use an arrow function, which is another very common syntax in JavaScript. An arrow function doesn't have a name. So this function right here has a name, say hi. If I console.log say hi, and then we refresh our page here, it's going to give us all of the information about the function. You might think that this would call it, but it only calls it if we put our parentheses on the end. Instead, a function is just another type of data. So we can put it into a variable, we can print out what type it is. Unless we use parentheses to call it, we can just get properties about it. And in this case, we print out the name, what's inside of it, the whole thing like that. We do the same thing with an anonymous function here. I print this. See, this one doesn't have a name. All it has is parameters that go through here, and then it has stuff that is going to execute on the inside. So an arrow function is a function that doesn't have a name, and it's slightly shorter syntax, which you'll use a lot. There's functions everywhere in JavaScript. Oh my goodness, we definitely undershot on room availability. I'm so sorry, everyone. So our arrow function here does not have a name. If we just declare it, like it'll exist, but we have no way of referencing it or using it. So what we would do in that case is we would put it into a variable. And this variable now stores the reference to this function. And if we console.log hello world again, we'll go ahead and comment out this other one. Console.log say hi to. We refresh the page. Again, it prints our function. Our function doesn't have a name, but we can access the function through the variable. And if we want to call it, we can just invoke it. So it works exactly the same like a regular function, just a different syntax. The benefit here comes from when I start to introduce other arguments to our function. So whether we're using our function keyword or an arrow function, we can go ahead and put in parameters in here. So if we want to take in variable 1, we do not have to put any types on the variable, which is extremely dangerous. And you definitely want to be careful. But we could go ahead and print out whatever var1 is and concatenate it to the string. And now when we invoke this, we can pass in the number 3. Oop. And so now it prints hello world plus 3. So we can pass stuff in. This doesn't have a type. We can't specify a type in base JavaScript. So I could pass in 3. I could pass in another string and concatenate that. There's some really weird stuff you could do. I could pass in an array here and it'll try and concatenate that. That doesn't do anything. There's a lot of things that should not really be doable, but are doable. And what this means is if we have an anonymous function here, so I'm going to say anonymous function, arrow function, they mean the exact same thing, just something without a name. I can pass in an arrow function here as part of the parameters, and then we can invoke it here. I update this and we'll name it something to indicate that it's a function. We save this. Actually, let's do this a different way. We'll take our arrow function, we'll put it into a variable, which means we can use it again. And then we'll pass in the reference to the function, again, without the parentheses, which means we're not invoking it. And now, if we refresh the page, it prints out both of them. So we're calling say hi to, we're passing in a reference to a function. It'll first print the thing that it says, and then it'll call the other function we're passing in, which also prints something. We could also pass in just like a number here, and this is going to cause a problem. fn1 is not a function. We're trying to invoke something here, but this is just a number when we pass it in. This is really dangerous, and so you want to avoid this at all costs. But we can also just take our arrow function and we can pass it in just directly. Like we don't have to put it into a variable. We can just put it in here, no problem. So if we refresh this, this is totally valid. It'll do the same thing. Anytime we declare an arrow function, it just automatically gives us back a reference, which we either put into a variable or we put into an argument. Another cool thing, if you only have one line inside of your anonymous function, you can just take out the parentheses. and take out the semicolon at the end and literally just write the thing that you want it to do. And this also works the exact same way. There's a bunch of cool syntax here. I'm going to try and make this as like non-confusing as possible going forwards. Just want to like let you guys know all the crazy things that you can do. All right, off we go. Actually, hold on, one more thing. I lied. Let's comment this again. Let's create another function here. Call this test var1 console.log var1. So this just takes whatever goes in and prints it. If we call test with a value, then it'll go ahead and print that value. But we can also call test without giving it anything. If we don't give it anything, it prints undefined. There are two types in JavaScript that represent nothing. Undefined, which means there should be something here, but like we're the difference is sort of depending on usage. Undefined means like you've done something wrong. Null just means there's nothing here. So you can use null usually comes up if you do something intentionally and you want to represent something intentionally, there's nothing. Undefined usually happens when you do something wrong that you should have done. In this case, we expect something in here that we're trying to use, but we can't do anything with it. Maybe I thought this was going to be another function that we could call, and I try and invoke it. Then we have an error because like undefined is not a function. We can't do anything with it. So lots of ways that you can go wrong as usual. Let me check what the question is here. Yes, there'll be a recording of this workshop later. There'll be slides. There'll be everything.
Not really related, but does anyone have a USB-C charger for a laptop?
Don't think I do, unfortunately. I have one at home.
Got one.
All right.
Thank you very much.
Outsourcing the problem. I like it. All right, here we go. On to the next thing. So we've done some cool stuff with functions. You'll be writing a lot of functions. That's just how it always goes. You can choose whatever syntax is most pleasant to you, but totally your prerogative. Next cool thing we're going to talk about is arrays. So when I declare an array, probably I'm just going to operate on it. So I'm going to declare it as a constant here, which means I can't reassign this variable to something else. And an array can be declared literally with just brackets. So this is an empty array. We could put stuff in it by default. We can have literally any types in here. There is no strict requirement on what you can put in. If we console.log, all of these things are totally fine. You'll notice that the browser really helps you out because it lets you expand arrays and also objects to see what's inside and sort of like the whole tree. So we can see that in here, index 0 is 3, index 1 is a string 5, index 2 is a function, and that function, blah, blah, blah. It has stuff inside as well. So let's say that we made this empty by default. We can add to it with array.push. We can push 3. We'll push our same things that we just had in there. We'll log it at the bottom just to see what's going on. So again, we have two things in here. We can take stuff out if we want to by calling array.splice. And there's 3 things in here. VS Code is really nice because it tells you what everything is. We want to specify an index where we want to start messing with things. So let's say we'll start at the first index. How many things do we want to delete? We want to delete 1 thing. And at this point, that'll go ahead and take out our number 5 at the end. Other cool things you can do, you can get the length of the array. It is not a function, it is a property, so we don't need the parentheses at the end, like if it were a string in Java. So we can call array.length. We can access a specific part of the array like you would with any array. We'll also print array of 0. And let's print array of 3 just to see what happens. So if I refresh here, the first thing we print is the length of the array, which is 1 because we have 3 and then we took out the string at the end. And then we print the 0th element, which is that 3. And then there is nothing at index 3 because it's of length 1, and so we get undefined. We don't get an error, so it's not going to crash your program, but if you expect something to be there, it's going to be a problem. Cool. Here's another weird thing you can do. We could put something in, like we don't have to expand the size. We can literally just put it in whatever index we want, and the array will grow to that size. So if I want to put the number 9 in index 5, let's remove this from array here. So we're printing the whole array, which is 3 and then 4 empty spaces and then the number 9. And again, if we try and print what's at 0, well, there's a 3. If we try and print what's at 3, there's nothing. So you can access any part of the array and it'll expand the array as needed, but you can have slots that are undefined that are completely empty in the middle, which is dangerous, as you would expect. Other cool things you could do with an array. Let's say we have this array and we want to make it into another array. We want to make a bigger one. We can have a second array here, and let's say we want to add a bunch of fixed things. We can use a spread operator, which is 3 dots. This spread operator means take what's currently in there and just take all the elements and lay them out flat. So if I do this, so now we have these 3 things at the beginning of our new array. All of the items in array, all of the indices have been spread out, which started with 3 and has 4 undefined indexes, and then the number 9. So you can use your array over again. This is a pattern that does happen more so when you start dealing with, I don't know, if you get a little bit more heavy into web development and start using like JavaScript frameworks. I think that's where most commonly I've seen this used, but it's available in vanilla JavaScript as well. Other cool things, we can destructure. So let's say I want to get specific elements from in here. Actually, let's not use this one. This is dangerous. I'm going to create a new array here. And this will be hello, and then put in your name. If I want to get out the elements of this array and put them in their own variables for whatever reason, we could do that with a destructuring statement. And so what this does is it takes the 0th index and puts it in the first new variable, and the first index and puts it in the second new variable. And then we can go ahead and use this if we wanted to. And if we refresh this, it'll go ahead and concatenate our strings. So if you want to take stuff out of an array and assign it into separate variables, you can do that with destructuring. The alternative to the destructuring here is like const var1 is equal to array 3 index 0, and then do another line var2 array 3 1. So saves you a lot of extra time, especially when it gets bigger. This is a pattern that happens a lot in React in particular. All right, so we did that. What else do we have here? Let's call some functions on these array. So array 3, if I have code completion here, if you're using like Notepad, you definitely do not. But there's a bunch of different properties we can use, index of, things that you've seen in other languages before. But we can also call functions like .map, which operate on the array and will give you back a new array. So map is really cool because if you have an array of a bunch of things and you want to turn it into an array of a bunch of different things that are based on that, then you can use map to take each element, perform some operation, and put it into a new array. So let's say I want to, I don't know what the best way to do this is. Let's say I want to turn these strings. This is not a good example. Let's do this. Create a new array, and this will just be a bunch of numbers. And let's say we want to turn all of these numbers into their string representations. So this is an array, but it's a different array, and it's all based on the original one. So what we do in here is we specify a function that we want to run on every single index. We're going to do this with arrow syntax here, just to make it easy rather than declaring it somewhere else, but you certainly could. And this really complicated signature here says that in our function, which they call a callback function, which means when this thing happens, I'm going to execute it, we can pass in the value of the current part of the array. So array value, we could also get the array index if we want to. We're not going to use that here. And in here, we want to return the result of some operation. So if we want to turn them into strings, a really easy way to do this would just be string concatenation. I should, and I was just about to do that. Thank you for the reminder. Res, we'll call this results. All right, if we go ahead and run this, we now have an array and everything's a string. We turned everything into a string. So map turns everything into something else, which comes up every once in a while. Note that because this is one line, actually, I don't know how you would do this without the brackets because it's not calling a function. If this were like calling a function, we could get rid of the brackets and just do it in one line. Now I'm curious. Does this work? This does not. Oh, it does work. Cool. So that works the same way. Again, because it's one line, we can get rid of the return, we can get rid of the brackets, and we can just write it in line like this. I'm going to go ahead and redo all of this just for clarity of what's happening. This is .map. Similarly, another one you'll use a lot is for each. Let's say I want to take array 4 and add something to every single number. So we can take array 4 dot for each and value, and then the function that we want to run on everything. And we can return value plus, I think I said 4 maybe. Const res 2. Res 2.
Why don't you just make res a variable or a let or whatever?
That is a great idea. Let's do that. That way we don't have to redeclare new variables in this case. I'll go ahead and take out this console log statement. I was going to do that in the function section, and I forgot to do that. So let's double back to that in just a second. Thank you. All right, so for each here, if we look, actually has a return type of void, which means it just does something and it doesn't reassign into a variable, which is why we were getting undefined. If I were to assign this into res and then try and do something with it, it prints undefined because it doesn't give us anything back. So instead, we just call this by itself, it executes, it does its thing, and then we can use array 4 here is what we want to show. What did I do? What did I do?
That since it's not returning a variable, then you just do the console.log inside for each. So that way, for each value in array 4, it prints the value or something like that.
Yeah, I guess it doesn't automatically put it back into the array. We could do that if we wanted to. Array 4 index is equal to value plus 4. And now if we print it, it's updated everything. Okay, that's interesting. Good to know. So you can perform some operation on everything, but it doesn't automatically like in this way, when we return something from map, it will go ahead and put it back into the same index of the new array. Whereas for each, it just does something. You could call a function, could do some math, but returning doesn't do anything. All right. Lots of self-discovery here. Let's go back to our function declaration. We had said earlier that let and var are mostly the same thing. The difference here, if we create a function, test function, and let's do if true, and then open block of code, let x equal to 3, and then console.log x outside. How many of you guys think this is going to work? Show of hands. Good. This is not going to work. Oh, it does work because I think I had x somewhere. Do I have it further up here? Everything out here. Let x equals 0. Hold on. I swear this is exactly what I wrote. Why does this not work? Oh, because I didn't call the function. I'm a dumbhead. All right. Remember, you got to call the functions that you declare, otherwise they don't do anything. So if I use let on the inside, we get an error. X is not defined. Let is block scoped. Block meaning I have opening curly brace, I have a closing curly brace somewhere for it. If I try and access it outside of that, it does not work. I can access it inside if I want to. That would be totally fine. But we can't access it outside. If I use var instead, how many of you guys think this is going to work? A couple people. This actually does work if I refresh over and over again. Var is functionally scoped, which means if I declare x in here, I can access it anywhere inside my function, which is another thing that like you would expect to just not work. And so if you don't know the difference and you use var unintentionally, it can cause some undefined behavior or things that you don't want to happen. The rule that I learned at my very first job was just use let. Unless you have like a very, very good reason to use var, just use let. If you do have a good reason to use var, you should probably just do something differently. So I would stick with let, but I have also had a couple of interviews where they asked me the difference, even if you don't use var for anything. So it is useful to know. Use const if you have a variable that doesn't need to change, use let otherwise. All right. That was everything for function. What? Okay. 2 more points, and then we're going to actually make something, which will hopefully be a lot less frantic following along. The next section we need to cover is objects, which is also super important. I have a section in here for classes, but because most of you have not like taken an object-oriented class before, I think we're just going to skip over it entirely. But objects are really important. So we can declare a literal object using curly braces, which is the same thing as you would in like a function or something like that, which occasionally can cause confusion and you'll do something wrong and then JavaScript won't understand it. But an object is just a bunch of key value pairs. So we can do, oh, I messed it up already. Foobar, what's another weird programming thing? Oh, we can do hello world. We can do fizz, buzz, knock out all the programming stereotypes. Anyone have any other good ones we can put in here? I think these are like the big 3. All right. So if we go ahead and print out the object, we can again expand it and we just have a bunch of key pairs. So when we're specifying the key, we do not need quotes, but our value in this case is a string. We could put literally anything in here. If we put a string as the key, this will also be fine. Test 3. Cool things. We could put another object in here. We can put a nested object, and then if we go into our Explorer, we can expand the second object. Do lots of cool stuff. This object has a bunch of things that are like properties of it by default, but when you declare a literal object, you specify what goes inside of it. And there's no like contract when you're handling an object. Like there might be a property in there, there might not be. Who knows? I can access a property, console.log object.foo, and we specified foo. It was bar, so this works. We can also specify something that doesn't exist. Maybe we try and get bar, and that'll give us undefined. So again, it doesn't cause an error. It just silently messes up, and it will cause problems down the line. We can also access a different way if we want to access something dynamically, like maybe I have a string here. We can access through console.log object and then square brackets, and we could put in any string or string variable, and this will work. It'll give us bar. Do lots of cool stuff. We said arrays have destructuring, where you assign it to multiple separate variables, and also spreading, where you take everything inside of it and lay it out flat. You can do the exact same things with objects. Someone's whispering. Is there like an issue that we can? All right. So if we have a new object, we can spread our old object in there. So maybe I want to replace one specific key only. So let's replace hello with your name instead of world. And then we can say spread out the rest of the properties of this other object here, obj we called it. Oh, because I didn't put a comma. After every key value pair, you need a comma except the last one. And then if we go ahead and console.log new object, if we expand our new object, our hello property, oops, I think I have to put this in front actually. Yeah, so now if we put it in front, it takes all the properties in objects, lays them out, puts them into the new object, and then we override the hello property, which existed in here, and reassign it to Eli. So now this is updated. So this is how we spread an object. We could also, I wonder if we can do this. I don't actually know what this does. Let's try it out. No, this does not work. So spreading an object works when you put it into a new object, but it doesn't like spread out the key value pairs into an array. Destructuring. We can also destructure if we want to get specific properties out. Destructuring for an object is curly braces to match the syntax rather than brackets to match that syntax. And so this new object has foo and fizz, so let's take those out. We can specify which properties we want to take out, and then the object we want to take them from. Oop, then I need to console.log all of these. All right, and then we get foo bar, fizz buzz, not a property, undefined. So again, the common theme here is there are errors in JavaScript, but there's not a lot of them. And a lot of things that you do that shouldn't work do work. And so you need to be super careful when you're doing them. All right, we got objects. Last thing that I want to cover here is equality. And then we'll move on to the fun stuff. All right, so there are two equal signs in JavaScript. Technically 3 if you count the assignment operator. So I can assign something with just a single equals, assign x to 3. If we want to compare something, x equal to 3, we can use either a double equals or a triple equals. In this case, both of these are going to return true. So you might think, oh, they're probably the same thing then. They're very much not the same thing. If I change this and I make this a string 3 instead, the first one says true and the second one says false. Double equals is loose, which means it'll try and coerce the type into something else if they don't match, and then compare, which leads to a lot of things that you would not expect to work. Triple equals means strict equality. They have to be exactly the same thing in order to have a value of true, which is usually what you want. But there are cases where you would want to compare two things without having to manually change it yourself. Other things we can do here, null is equal to undefined. If we use double equals, this is true because they both represent an absence of a thing. But if we do exact, this one is false because they are technically two different things. Another interesting thing is if we do 0, double equals undefined. Actually, let's do this on its own line here. These are both false. What if I did this? Does this work? Yeah. So the other thing is there's like a concept of truthy values and falsy values. And a lot of like base types have, if like most of them are in loose comparison true, and in strict comparison, like you can't even do it. In the case of numbers, 0 sort of represents false. And then if you have anything that's not 0, like this is a 1, then it updates from true to false, because now 1 is the truthy form of a number. Anything that's not 0 is truthy. And an empty string is the same thing for strings. I think an array would also work here, although I don't actually know. Yeah, so an empty array is loosely equal to 0. There's a lot of bogus garbage that you can do. If you like look for examples online of like comparisons in JavaScript that don't make any sense, there's so many like fun things where you can do like addition between things that are not the same and make like equations. It's insane. If again, like this is the same case as like let and var. If you know what you're doing, you can use a double equal, but usually you just want a triple equal. All right, that is enough of me just talking about things. So let's go ahead and turn this into a small project just to make things fun, or more fun than they are currently. I don't know if you guys are having fun. Let's go back to the link tree if you're not already there. So nighthacks.org/linktree. And down here, there is a workshop template section. And if you click on that, it'll take you to a zip file, which conveniently has a base skeleton of a tic-tac-toe game. So it has an index.html. It has a couple styles to make it look interesting. And it has 2 SVGs, which are images that are easily resizable. And we're going to use those to create a tic-tac-toe game. So go ahead and download that zip file and extract it. I hope everyone has the ability to extract something. I remember back to like 6th grade trying to like figure out how I can get a program on my Windows computer that would actually extract something. I had to like download WinRAR and get like a 7-day free trial. Was that just me or was that anyone else? All right, so we have some stuff in here. Let's go into the same folder that we were working in. And I'm going to create a folder just to hold this testing stuff, which means it's no longer going to work in the browser if I move it. So now it's going to cause an issue. But now we have that base folder again, and we're going to paste in all of those extra files, which I think I actually need to drag. So we should have an index, a styles, an O, and an X at the exact same level. Cool. And then I can go back in and we'll open wherever those files are in our workshop, we'll open index.html. This is not great. It's passable, but we have our tic-tac-toe board here. We have a header at the top, which we'll use to specify what is currently going on in the game. And then that's it. So right now it doesn't do anything. If I click on it, nothing happens because we don't have any JavaScript yet. So it's not interactive. It's just a bunch of static content. And let me just pull up this just to make sure that I'm doing everything correct as we go. What we're going to do is, if you notice in the index.html here, and we go all the way down, there is a script tag being imported, which means I want to take a JavaScript file and embed it into the page and have it execute. And it's called game.js, which does not exist. So we're going to create that right now. We can console.log test just to make sure it works. If we refresh the page, it should go ahead and print in our console test. So that's how you know that the script successfully got loaded. Very often, I will attempt to load a script and write the syntax incorrectly and do my whole thing and then wonder why nothing happens. And it takes me a good long time to realize that I did not load it properly. So always go ahead and test, just make sure that your script is successfully being run, which it is. And now we get to the fun stuff. So we have to represent our tic-tac-toe game, the state of the game, and then provide ways for the user to interact with the page in order to update that game. So let's do a couple of things. Let's create a game state object at the top. And this is going to be an array of 3 separate arrays. So this is a 2-dimensional array, 3, 3, 3. And let's fill it in originally with zeros. As a design choice, I'm going to say that 0 is the absence of a piece. Of course, you can do whatever you want. And then let's declare a couple of constants at the top that we can use in the future. One piece of advice that I got from Dr. Guha when I had him for Intro to C was, if you're going to reuse something over and over that doesn't change, it's a good idea to put it into like a constant variable that you can use. If it's like a number that from first viewing doesn't like make sense what it is in particular, you can put it into a variable and name that something more useful and then reuse the variable over and over again instead. And so instead of representing like a 0 is nothing, a 1 is an X, and a -1 is a 0, and then just like throwing a bunch of 1s and -1s in our code willy-nilly, we can say that an X, the variable X represents our 1, the variable O represents -1, const empty is equal to 0, which is what we defined. And so now anytime we want to reference like and check, is this piece an X, we can just use X in our code, and anyone who looks at it is going to immediately know that this is an X. Let's declare a variable here to hold whose turn it is. So right now it is the X player's turn. Maybe that's the theater group at the end of the hallway. I have no idea. So let's say that the turn starts with the player who is X. Cool. So things that we're going to need in the future, which I'll go ahead and create a comment just so we remember what we still have to build. We need a function to update the label. So this label up here right now says placeholder. This is what is statically defined in our HTML. We want this to eventually say whose turn it is, and every time someone takes a turn, update it to be the other person. So we're going to need a function to do that. We're going to need a way to capture clicks on a square and game logic. So when they click on a square, they try and place their piece there. If there's already a piece there, we don't let it happen. And then we're also going to create a function to repaint the board, which means take everything out and repaint the state, inserting pieces into the squares that it needs to be. Right now it's empty. but eventually we'd like to have those X and O SVGs in the boxes that are representing the game state. And there might be some smaller things that I'm forgetting, but let's start with the function to update the label first, because this is the easiest thing. We're going to create a function. I'm just going to name it. So we don't really need an arrow syntax here, so I'm just going to leave it as a function. Update label. And so let's get the label. One cool thing about JavaScript in the browser is that you can actually like access elements in the page. And the way we do that is by getting the document, which represents the whole page. And we can do a bunch of things. We can get elements in it. We can create an element and insert it dynamically with JavaScript, which is also really cool. In this case, we want to use the query selector, which will get one specific element that matches some specifier that we're going to put in a second. We could also use query selector all if we have multiple things that match the same query, then it'll return an array with all those things. But we only have one header, so we're just going to use query selector. We're going to figure out how can we actually get this. So let's say that this ID did not exist, and we want to get this H1 element. There's not a good way of doing this. We could look for an H1 element. In this case, there's only one, so it would be fine. But if we have a really big page, there will be lots of headers, lots of paragraphs. So that's not really feasible. We could look for a header that has the text placeholder in it, but it's going to change every time we update it. So that would only work once. So what we can do is we can specify an ID for our tag here, which says this tag is uniquely identified by this ID. No other tag can have the same thing. And I think we called this game status. So let's look for, in our query selector, we specify what we want to look for. We're going to look for an ID, which we use a # for, and then update, game status. Is that correct? Yeah, ID of game status. A class is something that you can apply to lots of different elements and then access all of them using the class, whether it be for styling or for grabbing them all with query selector all. You'll notice that our cells here, which are these red boxes, they all have unique IDs, the number that represents them. So we can get cell 0 if we need to, but we can also get all the cells at once with this class cell. And we could do that with query selector all, and instead of a # dot cell. That would get our cells, which we'll do later on. Okay, so we have the label. We want to update label.text content to be, let's check whose turn it is. If turn is equal to X, then player X's turn, that's English. Otherwise, player O's turn. And if we reload the page, it's not going to update our placeholder automatically because it's just a function. We haven't called it yet. And what I'm going to do is I'm going to go to the very bottom and I'm going to call update label, which means as we're going through this script, like running it, it'll eventually get to the very bottom and it'll call update label for the first time right when the script gets loaded and executed. Most of the things, if you're using JavaScript on your front end, will happen later on. JavaScript is an events-based language when used in the browser in particular, which means we listen for events. So our script is still running. It will have run from top to bottom, but it'll still be listening for things. And when those things happen, then it goes back into the script. It grabs the function you tell it to run when that thing happens, and then it'll execute it and do some other stuff. So it goes top to bottom, which means eventually you get to update label. But the other things we want, like capturing clicks on a square, that'll be an event. We listen for the click event, and then we tell it when that happens, I want to do all of this game logic. And we'll do that very, very quickly here. I zoomed in way too far. I think if I save this, no, it wants to put it all on one line. You just zoom out here for a second. You can put this all in one line. This is a ternary operator if you haven't seen it before. Python does ternaries a little bit differently because it uses like actual words. I don't remember what the words are offhand. That's how long it's been. But most other languages use a question mark, which means there's a condition on the left. If that condition is true, do the first thing, otherwise do the second thing. In this case, we're going to set the text content to be, if it's player X's turn, the string that says it's player X's turn. Otherwise, the string that says 0. All right, I'm going to keep moving here. If we reload the page now, it'll go ahead and update because our script executes once from beginning to end, and it'll call this update later. We still can't do anything, and it still doesn't change, but we'll use this again in the future. Next thing that we need to do is we need to capture clicks on a square. And the way we're going to do that is we are going to get every single element with the class cell. All of our cells are these squares. So we can use our query selector all that we just talked about. All cells, document, query selector, all dot cell. If I console.log this here, and I open my console, you'll see it comes back with a list of nodes, a node being your element and all of the information that is kept about how it looks and how it operates. So if we wanted to get like the first one that comes back, we could access the 0th index of this list. And then there's so many properties attached to all of these elements. You could get all kinds of things if you want to. We're not going to do that. Instead, what we're going to do is we're going to do all cells dot for each. So we're going to use that for each that we covered earlier, where for every single thing in this list, we're going to do something to it. And we're going to call cell.add event listener. Click. And then specify an arrow function of something that it's going to do, which right now is nothing, but we'll fill that out. Any questions about what's going on here? Does everyone follow what this is doing?
Does it initialize some sort of like, it's like listening thing? That
Exactly.
is always there?
That's what most things on the web are. They are listening for some particular event, doing something in response, and updating the state of your page. So we're listening for a click. We'll call some code that will go ahead and perform the action. And then if we need to, if something has changed, we'll call our repaint function, which modifies the elements in the page so that it updates what's actually there.
Wait, what is that add event?
Add event listener means I'm going to, for this particular element that I have, we have a reference to a particular cell with this for each. This returns in a list of all of our cell elements. And then on each one, we're going to add a listener, which will persist. Because again, our JavaScript, when it gets loaded, it gets executed from top to bottom one time. And the only way to have something happen after that is to add a listener that persists and listens for something to happen. Or you can set a timeout, which will happen in a certain amount of seconds, or something that happens later. And listeners are the primary way of doing that. There's a click, there's a mouse over if you just like move your mouse onto something, a mouse out, I think. If you have a button, you can listen for a button click. There's lots and lots of events that you can listen for, depending on the element that you have. Which is why there is a string here. The string is the type of event that you're listening for. In this case, we want to click, but we could change this to mouse over, I think is the event. And that would also work. We're going to keep this as a click. If we want a reference to the actual event itself, then we can put it in here. These events usually return back a reference to the event that happened. I don't think we need this here, so I'm going to keep it out. And here's what we're going to do. We are going to figure out which cell they clicked and what row and column it corresponds to. We're going to look in our game state, and we're going to check if there's already something there. If they click on a cell that's already filled, then we don't want to do anything. If there's not something there, we'll put the piece in there. And then if that happens, if we do put something in there and our game changes, we'll go ahead and call our repaints to make it like refill the X's and O's in our board. So let's start with first thing. So we needed to get the cell itself, cell.id, which gets us this number here. So cell 0 is up here, 1, 2, 3, 4, 5, 6, 7, 8. I've added some CSS in our styles.css in our game table, where each row and column has 3 things. If I didn't have these lines in here, let's actually experiment with that for a second. If I took these lines out, now it's just one after another, and that's not super helpful. So instead, we have rows and columns, and they're all square. Okay, so our cell.id gets us the number. And let's use this number to figure out what row it's in. So the math trick here that we're going to use is our row is equal to cell ID divided by 3. And our call is equal to cell ID mod 3. So if it's 0, 1, and 2, this integer division, which right now it's not integer division, like all numbers in JavaScript are one number type. And so if you try, it doesn't do integer division unless you tell it to use math.floor. So math.floor means do this division and then round it down. So if it's 0, 1, or 2, it'll round down to 0. If it's 3, 4, or 5, it'll round down to 1. And if it's 6, 7, or 8, it will round down to 3. And so that's how we get our row. And then mod means what's the remainder of this? 0 divided by 3 has no remainder, so it's just 0. 1 divided by 3 has a remainder of 1. 2 divided by 3 has a remainder of 2. And so we can get the column 2. And we're going to use this. We're going to check if grid row call is equal to empty. Triple equals, again. Empty is a 0 in this case, so this could actually be really scary if we used a double equal. I don't know what would happen, but loose comparison could be an issue. But if it's empty, again, we said we're just going to reference what state our cell is using these constants instead. Yes, I called it grid when I made this originally. You are absolutely right. Game state row of columns empty, then we just want to return. Sorry, if it's not equal to empty. So when we do not equal in JavaScript, one of the equal signs becomes the exclamation point. If we have a triple equal, then we have an exclamation and then 2 equals. So this is strictly not equals. That's what we're saying here. If it's not empty, if there's a piece in there, then we want to return. Otherwise, game state row call is equal to turn. Whoever's turn it is, place that piece in there. Turn is equal to, this is the easiest way that I could think of to do this, just make it the other one. It's another ternary. If it's X player's turn, make it O, otherwise make it X. And then we want to call repaint, which we haven't officially done anything yet. This function does not exist. But at this point, let's call console.log game state. I'm going to full screen this for a second. Or not full screen. We'll leave this slightly larger. All right. For those of you who are still writing, is that visible? All right. So if I go into my console here, if I click on a cell, it's going to tell me repaint is not defined because we haven't actually done it yet. So let's go ahead and declare our function repaint. We'll say this is to do. I have an extension in VS Code that highlights to-dos in a different color just so that they're more noticeable, just nice. But now if we click on a cell, if it actually worked, then it'll go ahead and print out the updated thing. So now we have a 1, which represents X in that top left corner. We did not call update label, so we should do that after we change the turn. So now it updates to player O's turn, and we have an X in the top left corner. If I'm player O and I try and click there again, it doesn't do anything because this check here, if the game state is not empty, returns before we do anything. And so it doesn't even print. I can go somewhere else. And now if I open this again, there's an X in the top left and an O in the top middle. Can click all of these once. And now they're all filled with something. And if I click anywhere, it doesn't update. Cool. Any questions here before we move on to the last function? All right. So the last thing we need to do is we need to actually modify our page so that when our game state changes, it'll insert X's and O's where it needs to go. The way that I've defined this HTML structure is we're representing the table as a div element, which means just a box, an empty box. There's nothing in there unless you style it so. But you can put things in there. So all of these cells are also divs, which means they're also boxes. So I can put an element into each of these divs, which we're going to do. We're going to put our X's and O's into image elements, and we're going to put the image inside of the cell. All right, and this is the part that I always forget how to do. So I'm going to very quickly glance and cheat off of my notes. Okay, here we go. So our repaint needs to do a bunch of things. Let's go ahead and outline things in advance because it is always helpful to be organized. First, we need to iterate through all slots in the grid. After that, for each one, we need to remove whatever piece is in there. Actually, we can go ahead and skip this. We don't really need to remove anything. We only need to insert new elements. I'm going to remove it anyway, just so you guys can see how that works, and then we'll take it out because it is unnecessary. And then once we do that, if a particular piece should be in there, create the new elements, append it into the cell. All right, let's start at step one. How can we iterate through everything in the grid? Pretty easy to do. We can just use a for loop. Let row is equal to 0, row is less than 3, row plus plus. So this goes 0, 1, 2. Or let's call is equal to 0, call is less than 3, call plus plus. This will go from columns 0 to 2. And then let's get the cell element. Document.query selector. Let's actually use a different method here just to show you that we can do something else. There's also get elements by ID. So let's calculate what the cell ID that represents this part of the grid is. We're basically going to do the exact opposite of what we did up here. So we have the row in the call. Now we need to turn it into the 0 through 8 number. So we're going to say row times 3 plus call. And then get element by ID, whatever that cell ID is. In this case, if we're getting element by ID, we won't have to put like the hashtag if we put a string in there, just because it knows it's an ID. Let's console.log cell elements. Let's refresh the page and click on here. Oh, I called this R, not row. And so now it's going to print out the element that we have, and we can do some cool stuff with it. All right, Let's check if cell. Let's check if game state. So the second thing is we want to remove whatever piece is in there. We could go ahead and do actually, let's not do this. Let's go ahead and skip out for now. We'll go back to that later. What we're going to do is we're going to if game state row call is not equal to empty, which means we don't need to put anything in there yet, then we're just going to return, sorry, not return. We're going to continue, which means go to the next iteration of this loop and skip over everything else in this iteration. So if it's empty, there's no piece in there, we don't need to create anything, nothing crazy like that. Otherwise, what we're going to do is we're going to say let new piece equal to document.create elements. We're going to create an image element, which is where we're going to house our SVGs. We're going to take the new piece and add class. No, class.
JavaScript, is there a difference between opportunity and quotation?
No, they're exactly the same. If you have a formatter, usually the formatter will have an option for use single quotes or double quotes. So that way you can be consistent and it'll automatically update it. Like if I were to put something in here in single quotes and then save it, my formatter turns it to double quotes on that. There is no difference. All right, so let's take new piece and let's get the class list, which is a list of all of the classes we have attached to it. If we were to have a reference to one of these cells, then it would have one part in that array that comes back and it would be cell. Let's take the class list and let's add, since that's what we get back. Let's add something that we can use to identify that this is a piece. So let's call this dot piece. And we can set new piece dot source. The source is what piece of media we're putting into this image element. And because we have it locally, we can just specify the relative location. If we wanted to get it from online, we could specify a URL in here. But we don't actually have to go any further. Like if we had, if maybe these O's and X's were in the test folder, we could do test/o.svg, but we don't actually need that because they're at the same level. So we can just specify the file name. And the source should be if, let me close this again, game state row calls equal to X, then x.svg. This is lowercase, yeah. Otherwise, we'll give it o.svg. So again, I'm a huge proponent of the ternary operator. It is awesome. And so now the source is set, but this element still just exists in JavaScript. That doesn't exist in our document yet. Now we need to call cell element dot append child new piece. And that'll be it.
So after you append it, I know it's not going to change the HTML, but if you wanted to do that piece, like if you wanted to write that piece in the HTML, how would you do that?
This is maybe not exactly what we're hoping is going to happen, but appending the child puts it into the HTML. That's all you need to do. The reason why it's not working right now is because if I click on the same cell more than once, if I click on this cell, it puts one piece in. If I click on another cell, now it puts two pieces in that original square. If I click on another cell, now it's three pieces in that original square. Every time we repaint the board, it just puts a new child into that cell box. We don't take any out. We always put a new one in. And every time we repaint the board, it just puts another thing in that box. So now we have 2, 3, 4, blah, blah, blah. Which we don't want. We only want one piece. So there's two things we could do here. We could check if there's already a child in there, a piece child, and then if so, not create our new element and append it. This, would be the smarter way of doing things probably, but because we only have like 9 total pieces, we can do things a little bit inefficiently, like time-wise, just because it doesn't matter. It's so small that it doesn't really change anything. So this was what I was saying earlier about we should take out the old pieces when we repaint and then put in a new one every time. So whatever pieces are in there, we'll take it out and then we'll append whatever's supposed to be in there. So let's do that outside of our for loop at the beginning. Let's do document.query selector all dot piece, which is the class that we gave it down here to reference that it is a piece. Again, classes and IDs are totally arbitrary. You can call it whatever you want that allows you to reference it in the future. And for each, we're going to run a function. And we're going to give it the one argument of the thing that we're currently operating on. And we're going to call piece dot, I think it's removes node. And if you do it in one line like this, there's no semicolon at the end, there's no braces, but we could also do this. This is also perfectly valid. So now, at the very beginning, it gets all the pieces in the game, takes them out when it repaints, and then we go through each grid's element, which now is completely empty, and everywhere there should be a piece, it puts it in there. Let's check if this worked. Oh, it didn't work. Did I spell something wrong? Query selector all dot piece for each piece dot remove. I'm going to print out what comes back from query selector all just to see if it matches what I expect it should. So it's giving us back the cells rather than the pieces. For each piece. But this should be getting us back our piece elements. When we console.log everything that comes back from this query selector, the thing that comes back is the cell itself. And then we can expand it and see that the piece is inside. I don't know why it's doing this, to be honest with you guys. Cells. Oh, you know what? We're going to take the period out of adding to the class list. This would be adding dot period as the name of the class, which we don't want. The period just helps us identify when we're query selecting this thing, this piece of string is a class. So we're adding just class to it. And then dot piece means get the class that is named piece. There we go. So right now, there's no like logic in here that checks if someone's won and like stops the game or anything like that. So we could keep playing even if the game is over. That would be something that you could work on in the future. Write some JavaScript so that when you repaint, if you find that someone has won, stop the game, don't let anyone play anymore, and maybe like change the color of the cell so that it's green if they won or something like that, or change it to yellow if they draw. You do some fun stuff. that is all of our JavaScript for creating this game. We did a lot of cool things, tried a bunch of different concepts. And yeah, it's pretty cool. So this is our vanilla JavaScript program. There's no special things involved in here. I do have like surprisingly a bunch more content after this. It's like we're already an hour and a half in. So if anyone has anywhere to be, by all means, you're welcome to leave. But there will be a couple more slides, just to talk about some more higher level concepts. And then we'll talk about other ways you can run JavaScript after that. The code for everything that we do today is on our link tree. So if you are leaving and you want to look into the rest of it, there's, oh, I didn't put it on the link tree. Never mind. I'll put it on the link tree after this, but there's a repository for this. Okay, let's go back into the slides here. I don't want to present and record. I just want to present. Okay, so what we did is we wrote a bunch of JavaScript, and it all runs in the browser when we go to a specific page, which is cool. But if you're not interested in web development, then like there's no reason for you to know JavaScript or even like care about it at all. So there's other ways that you can use JavaScript as well. JavaScript, because it's a scripting language, all it needs is an executor or a runtime or an engine in order to take all of the code in there, do just-in-time compilation, which means when it gets to the thing that it needs, it'll go ahead and compile it and execute it. Like we said earlier, all the browsers have their own engine built into it. Chrome calls their engine V8 and it's open source, but Chrome executes JavaScript differently from somewhere else. But there are runtimes that exist outside of the browser as well. If you've heard of Node.js, Node.js is the most common runtime outside of a browser. You can run that literally on any computer and just execute JavaScript like a normal program. It doesn't have any interaction with the browser if you do that. That's why it's called server side. Like client side is synonymous with browser for the most part. There's no interaction with the browser. It just exists on its own. There's other runtimes that do the same thing. Dino was invented in 2018, surprisingly by the same guy that made Node.js. And it was just to fix a bunch of issues with Node.js. Bun is even more recent than that, and is designed to be really, really, really fast. There are upsides and downsides of using one or the other. Because Node has been around the longest, there's the most support for like packages that you can use with Node. And also, if you run into an issue, there's more likely to be Stack Overflow posts telling you what to do if you use Node than something else. I personally have not tried the other two yet. I would like to at some point, but Node.js is the most popular, and that's what we'll use a little bit at the very end for those of you who have it installed. There are runtimes for other kinds of things as well. If you want to run it on like a little piece of hardware, you can run it on embedded systems. I personally have never seen anyone do this. Usually, if you have a little tiny embedded system like that, you're focused on performance. And so you'll use, a C or a C++ or a Python even. And when you have a runtime, you have access to all these other crazy applications that you can make instead with JavaScript that are completely independent from the web. So if you want to just create a regular program that executes Java and does something, executes JavaScript, you can use packages that other people have created and published online, which have a bunch of JavaScript in them that does things for you, and then you just call a function and it does all the hard work. You can create your own packages and upload them if you want to. You can import other people's packages. If I go to the registry, so if you're using Node, NPM is the way that you can manage your packages with Node. And if I look even for something like time, I get 26,000 results. There's a lot of packages on there. There's probably a package for anything that you're doing, and you can create your own if there's not. Just a lot of buttons to press to get into the presentation mode. You can also, if you are interested in doing web development, you can do web development smarter. So there's a lot of things that modern web applications, like you just want to have, like a bunch of fancy animations, have some sort of interactivity, have ways to easily get data from somewhere and then populate it, like maybe if a user has an account. And these things require a lot of code to actually make happen. And so you can use a UI framework. If you've heard of React before, React is a framework. There's plenty of others that we'll talk about in the future to handle most of the minutia for you. And then you can just focus on what your application needs to uniquely have. These all require some learning because it's not like they implement things that are not available in vanilla JavaScript, but it all boils down to vanilla JavaScript in the end. You'll eventually compile it into like a static JavaScript application. You can also write outside of the browser, and you can write your own server somewhere that does all of the operations behind the scenes, manages your data, performs operations. You can write that with JavaScript if you want to. A lot of them will be written in all kinds of different languages. I know where I worked over the summer was primarily written in Java. That's where all of our services were. You can do it with JavaScript as well using the Express framework if you want to. You can write desktop apps. So outside of the client, you can write JavaScript using your favorite UI framework and then put it into a desktop app that you can like click on your taskbar, which is pretty cool. Make mobile apps. You can make apps for both iOS and Android, which are, if you write them natively for one or the other, in totally different languages. So you can do all these things with only knowing one thing, only one language, and that's pretty cool. You can make bots. If you're interested in making a Discord bot, there's a Discord library for JavaScript. There's one for a lot of different languages as well. Bots are really interesting because they're really standalone programs that interact with an API somewhere. Discord provides all of these different operations that they allow you to send requests to do. And any language that has the ability to like send a web request somewhere has the ability to make a Discord bot. And so JavaScript has its own library for that. Go has its own library for that, all kinds of cool things. What is the question in here? Thanks for coming. All right, this is the section where I'm just going to throw a bunch of words at you. Some of these words you may have heard before, some of them you may not. These are all just things related to the web that if you are interested in web development, at some point, you'll probably need to learn. The first thing we're going to start with is TypeScript. How many of you guys have like heard of TypeScript before? All right, pretty much everyone. So as you have hopefully noticed by all of the JavaScript that we've written today, JavaScript does some like really weird shit and some things that you would not expect it to do and has a lot of undefined behavior. If you send in a parameter to a function, it could be anything. Like I can send whatever I want and you can't stop me from doing that. TypeScript, on the other hand, enforces types on your variables. So when you create a variable, it has to be that type if you reassign it, which means all of the things that you write incorrectly that are eventually going to like result in something being undefined unexpectedly. Instead, TypeScript will catch that, not let you do it when you're writing the code, and then when you execute, you have peace of mind that everything is going to work as expected. It takes longer in order to actually write the thing you're doing, but it prevents you from spending 7 hours later trying to fix this little tiny issue that breaks your entire site. So if you're interested in JavaScript, there's basically no reason not to get started with TypeScript. I wouldn't start like right away, but once you're comfortable a little bit with the syntax, TypeScript is super, super helpful. The cool thing about TypeScript is it's just a superset, which means you can write any valid JavaScript and there's also valid TypeScript. TypeScript just adds extra things to it to enforce type safety. And in the end, after you set everything up, it all compiles into JavaScript anyway. So before you run it, you'll have to compile it into JavaScript at some point, but all of your development can be in TypeScript. The learning curve can be a little bit steep. There's a lot of setup required in order to make it actually work on your computer. You have to like create a config, you have to install it, you have to figure out how to build it. There's lots of different ways you can build it. But once you do that, you can usually use the exact same setup for all of your programs. So you only really need to do it once with a couple of modifications. Next buzzword that you may have heard before, frameworks. As we mentioned earlier, frameworks just let you write something a lot faster because it takes all of the things that are common to every application and does it for you. There's frameworks for the front end, the stuff that the user sees, React, Angular, Svelte, Vue, Bootstrap. We're going to have another workshop on Svelte probably next week. So if you're interested in more JavaScript, there's more JavaScript on the way. But there's also frameworks for if you're creating a server somewhere. Django and Flask run in Python. Laravel is PHP, Express.js is JavaScript, ASP.NET is C#. There's probably a language framework for whatever language you use. Bundlers. So if you're using, this doesn't really apply as much if you're just writing, it doesn't apply at all if you're just writing vanilla HTML and CSS. But if you're using a runtime like Node, you can install other people's packages, but this creates like a really complex web of dependencies. You might depend on something, and those depend on other things, and those depend on other things. And in the end, there's a lot of JavaScript that is required in order to actually make the thing that you set up work. And so all of that, before you can like run it correctly on a web page, it all has to be bundled together and compiled down into like a couple of very long, very unreadable JavaScript files. If I go into the inspect section of this browser, and I go into sources, in here, these are all of the things that are required in order to make this run. There's a bunch of images, and there's just a lot of JavaScript files. And if I open these, they're like very unreadable. Let's see if I can make this bigger. It's just like a bunch of garbage characters. No human can read this. No human wrote this. Instead, someone wrote a bunch of JavaScript that depends on other things. And a bundler came along at the very end when they were building it, put all the JavaScript together, did a bunch of auto generation. And now we just have a couple of vanilla JavaScript files that the browser knows how to deal with. If I write TypeScript, the browser doesn't know how to read TypeScript. And so it has to all be pulled together. The browser also doesn't know how to natively like put a bunch of things together using the UI framework, and so the bundler has to help with that. If you've messed around with React before, by default, you would have to set up your own bundler to make everything work, which is a huge pain in the ass. So instead, if anyone has heard of create React app, it's a command that is available that sets up a bundler and all of the pre-configuration for you, so you don't have to worry about any of that. Occasionally, you do break this, and if you don't understand how the bundler works, then trying to fix it is a huge nightmare, and this happens a lot. But bundlers are super, super important, and they do a lot of good things for you. All right, getting close, I promise. All right, more buzzwords. An API. An API is basically just a standard for interaction. So the way that websites are structured is the front end is everything the user sees, the client. And the client, when it wants to do something or it wants to get data to populate, like I could write just a normal HTML file, but if I have like user account, I can't like hard code a specific user into an HTML file. And instead, what I have to do is I have to go get that from somewhere, from a server that someone has created. And on that server, there will be some sort of API which specifies how I'm allowed to request for information. The different types of APIs just specify how that interaction needs to happen. The most common would be a REST API. That's based off of like HTTP requests. And there's a bunch of different types. There's a GET request, there's a POST request, a delete request. They all do a different kind of action. A GET means I'm going to get information from the server. I just want something back. A POST means I'm giving you something and you're going to do something with it. A delete means there's something on the server that I want removed. And your REST API, the developer says, I'm only going to allow you to do these specific things. It's very contractual. I'm going to tell you what you're allowed to send me, what you need to send me. And then I'm going to do my thing and I'm going to tell you what's coming back as well. And all of those are at different routes, which means if I go to, like in this URL, there is a route for /design/ some really long ID that probably represents this presentation /edit. And that route tells the server what specifically is going to happen. What type of request it is also can differentiate. Like you could have the same route /edit, and you could have a GET request there. You could have a POST request, and they would all do separate things. So together, it all defines what you want to happen, and the developer of the server can specify all of those things in their API definition. There's also other ways of doing this as well. You can use GraphQL, which is a huge beast to try and understand what's going on. But GraphQL has some extra flexibility where it's less contractual. Like I can choose what data I want to get back. as the client, like they specify like a set of data that I'm allowed to request for, and I specify which pieces in particular I want, which is useful because oftentimes if you send a request to a specific route in your REST API, you'll get a lot of things back that the developer has said you're going to get all of these things every time, but maybe you only need like half of them, or maybe you just need one thing. The rest of it was all wasteful. So GraphQL lets you specify, oh, I only want this one thing back. RPC, I'm not super familiar with. This stands for remote procedure call. As far as I can tell, the client tells a server somewhere what it wants, like some procedure it wants to happen and some parameters. And then the server, like on its native operating system, performs that procedure and sends stuff back. So the interaction is similar for all of these different types of server APIs, just the way that you send information and receive it is what's different. All right, this is seriously just an amalgam of all kinds of things that I think might be helpful if you're interested in web development. They're not all related to each other. Search engine optimization. So if you are making a website, you most of the time want people to be able to find it very quickly on a Google search. If you don't show up on a Google search, then no one's going to find your website and you're not going to have any traffic and you're not going to make any money from it. So what you can do is you can do small little things to your website that help search engines understand your content better and rank it more effectively for searches that should match your site. So if I have better SEO, then when someone searches for something that my site should theoretically pop up for, then it's going to be higher in the list than if I had poor SEO, which depending on what you're doing, you may or may not care about that. But it is still something to keep in mind, especially if you're like making a real project that needs to like generate revenue. The way that like search engines works is they send out automated processes called web crawlers, and they go through literally every single available web page. They look through all the content and they create an index, which just helps it find it faster based on the information available. The same concept exists in a database as well. If I wanted to find like one specific record in the database, if that database is enormous, then I have to search through a lot of things. Databases create indexes so that if I'm searching for a specific like kind of property, I can set up the database so that it's a lot easier to find. I don't have to scan through as many things. And so this is kind of how search engines work as well. Some things you could do, create like a meta tag in the header of your page, which tells information about the site that doesn't like appear visually. You can enable certain pages and features that the robots are allowed to see. There's lots and lots of factors. It's very complicated. You probably don't need to worry about it too much until you like get into a job. All right, in the home stretch. All right, we're going to talk about different kinds of rendering. If you pursue front-end web development, eventually when you start talking about different frameworks, you'll run into different kinds of rendering, like client-side rendering, server-side rendering. There's other ones as well that are more experimental, but those are like the main two. And in client-side rendering, the browser will use a lot of JavaScript to build the entire page. So if you have something that's really complex and depends on a lot of data that you can't represent in a base HTML page, a lot of the page will be built through that JavaScript in client-side rendering. So the client will send a response to or a request to the server for give me this page that I want to go to. And the browser sends it back a lot of JavaScript that tells how to build the page. And then the client itself renders the page from all of that JavaScript. This can take a while because you don't have anything there until it's done. There's no base HTML page that comes back that's at least viewable, even if it's not like usable yet, at least the content is there. It's all built dynamically through JavaScript. So it may take a little while for it to happen, but eventually it will at some point become viewable and interactable. It may take a little while. The contrary here is server-side rendering, where the server renders an HTML page already with the elements that you want in there and stylings applied. And then it sends that back down to the browser instead, and then a much smaller JavaScript file that just tells like little modifications to make to it. So the page you get back originally that's rendered by the server is viewable, but it's not interactable yet. The JavaScript that you download allows you to interact and click on things and do stuff like that. So this is just a different way of doing things. Certain frameworks will use one over the other. Depending on what you're making your site for, you may want one over the other. So server-side rendering is a lot easier for search engines to find because the HTML, that web crawler will request a specific page from the server. And if it gets back to HTML already, it has all the elements in there. It doesn't need to do any extra work. So it's a lot easier to index than something where it has to build a bunch of things with JavaScript. It's also viewable faster because you just get the page and then you just show the page immediately. It may not be interactable right away, but it'll at least be viewable faster. However, it does mean that every time you want to go to a new page, you have to ask the server to re-render a new page for you, which is a lot. If you have a poor connection or your server is not very powerful, this can cause problems. If the server's not powerful and you have too many requests going, then eventually it's going to overload. If you have a poor connection and every time you have to send a new request, then some of those are not going to go through. The contrary is client-side rendering, where it's less load on the server because most of the things that happen within the page are done on the client side. So you only have to get the one thing from the server, and then you don't always have to constantly get like every time you change the page. It's also really fast after the initial load is finished because everything's there. You don't have to constantly be getting new information from the server. It's slower to be viewable because, of course, it has to build it all, which takes longer. And the download of the JavaScript is way longer than downloading a little tiny piece from the server if it's already pre-rendered. And you have to have JavaScript in your browser enabled in order to actually build something. Whereas if you have a server-side rendered page, it's already built. So someone can go into their browser and disable JavaScript, which they might do if they don't want ads to show up or there's too much going on a page. But if your page depends on JavaScript to build it, then you're just screwed. The other thing here is that it's harder to index because it has to be built manually by the search engine robots, which will try to do their best, but it may not work, it may take longer. All right, last thing here, I promise. This is the last terminology, and then we'll do a really quick demo of Node, just so everyone can see, and then we'll dismiss from there. But the other thing to mention here is a server-side rendered thing. Every time you go to a new page, you have to request a new page from the server, and the server is going to render it and send it back to you, which is a lot of requests. A single page application is something that React does, among other frameworks. And basically, your entire application is literally in one page. You make one request to the server, you get all of the enormous JavaScript, and then JavaScript basically fakes that you're going to other pages. So the only thing that's changing is JavaScript moving around elements to simulate different kinds of pages, which helps because you don't have to like send another request to the server. And if you have a poor connection, like once you have the thing, you have it all and you can go ahead and keep using it. There's pros and cons to this, as always. You'll learn very quickly that computer science is just weighing pros and cons over and over again. But this is how something like React works, whereas there are other frameworks like Next, which use a lot more server-side rendering. Again, depends on what you're making, what you want it to be architected as. Yeah, that is everything in terms of content. I'm going to do a really quick demo of how Node.js works. If anyone has it on their computer, they're welcome to follow along. I don't want to wait for everyone to install it because we're already at the 2-hour mark. But I'm going to go ahead and set this up really quick. Folder Node. And then I'm going to open my terminal here. I'm going to use the cd command, which is change directory, to go into that folder. And then I'm going to run npm init. Once you install Node, you can create a new project with npm init, and it'll give us a bunch of things. We can name whatever the package we're creating is, test package, version, all of these things. Yes. And now what this has done, let me put this all into another folder here. No. And this package.json is how Node projects are structured. Every time we run JavaScript with Node, it needs to know a bunch of information about how your application is going to work, and that all basically goes through the package.json. So you have the name of our project, version, description. Main means like, where does it start? We have scripts which specify how we're actually going to start running it. Right now, there's no useful scripts in here. This does absolutely nothing, but we can create a start script. We can say node index.js. And now if we go in here and we create a file, which we called index.js, console.log, hello world, then when we go into that same folder, so inside of our node folder, if we run that script, npm run start, then it executes just like a standalone program. There's no interaction with the browser. We can do whatever we want here. If you want to do anything outside the browser, like create a desktop app, create a mobile app with React Native, or just run something that executes on your computer, you need like a runtime like Node or something in order to make it happen. So we can do lots of things. We can install packages here. Let's install TypeScript just to show you guys how TypeScript works very generally. And we'll save this as a dev dependency, which means this is only useful. Oh, I forgot the actual commands. npm I install something. And when we install, we can install it as a dependency or a dev dependency, which says if it's a dependency, when this is actually running in production, it's required in order to run it. Otherwise, a dev dependency only on your computer when you're developing it is it required. TypeScript is only really useful on your computer, not in production, because TypeScript isn't directly interpretable. It has to compile down to JavaScript. So if we did that, we now have a node modules folder, which is usually really big. If we create a React application, this would be like hundreds of folders. And this node modules has all of the things in there that our application needs in order to actually run, which right now is just TypeScript. There's a package lock.json, which is like the long dependency chain formatted so that everyone who's using your project can have the same installation. This node modules gets really big really fast. If you were committing this to Git, you would never want to do that. You would want to put it in the Git ignore. But now if I change this index.js to be index.ts, and let's create a tsconfig.json compiler. I'm going to speed through this. Out directory dist. All right, so anytime we have a TypeScript thing, we need to create a tsconfig, which is all of the instructions about how TypeScript is going to compile your things. There's so many to explore. If you're interested, I would definitely encourage you to do it. But now this is a TypeScript file instead of a JavaScript file. So if I create a function here, test function, something, console.log, something. This is like totally normal JavaScript. But if we hover over here, it has an any type, which is really dangerous. It could be anything in the world. And so in order to like have some safety about knowing what this is, we can add a type. We can say this has to be a string. We can also add a return type. Right now it returns void, but we can say this returns a number. And if we don't return anything in JavaScript, this would not cause a problem. But in TypeScript, we have to return a number now. And so it'll yell at us unless we do. And if we want to call test function, we can pass in hello. If we try and call test function and pass in something that's not a string, it'll yell at us. If we don't pass in the right things, it'll yell at us. It's all just to make your life a lot easier. You can use it as much or as little as you need. The baseline of TypeScript just helps you be safe, but there's a lot of more advanced ways to use it as well. And we can go ahead and compile this really quick. I promise this is the last thing. We can create a build script, tsc, npm run build, which will take TypeScript and compile it. We've specified that the output directory of TypeScript is going to be in a folder called outdir, which it just created, or dist rather. And now it's compiled our thing into valid JavaScript. And we can now run that. If we go back in here to our package.json, dist/index.js. and it goes and runs the file index.js. So it's pretty cool. TypeScript is really useful. If you're interested in the future, you can use it both if you're creating like a web browser thing, you can make it a node project and then compile it into regular JavaScript. Or if you're just making something outside the browser, TypeScript is really helpful. All right, that is it. I have thrown all of my things at you guys. Does anyone have any questions before we go? Anything they're curious about?
You need to know to use TypeScript.
Yes, you absolutely need Node to use TypeScript. So get used to it. Thank you everyone for coming. I really appreciate it. We will see you guys sometime next week. Have a good weekend, everyone.